Okay, this is the math behind why Mr. TommeyLeeReed is wrong in his video on Overunity. It's actually pretty simple. I'm going to write it out because, yeah, I'll just have to invert this later. Alright, so he says that 1 foot-pound, I can't spell for shit, so just ignore that, equals 12 psi. This is his one big mistake. Actually, it's his only mistake in his calculations. Because now I'm going to write this out. 1 foot-pound equals 1 foot extra O times 1 pound. Just use the abbreviation from now on. Just do that for everything. Okay, now psi is 1 pound per, that's divided by square inch. So that's IN squared. In other words, that's an inch times an inch down there. That's the big mistake, and admittedly this is all too uncommon a mistake. Now, this isn't, that's not to say that these are completely incompatible, but it just means that that is wrong. I gotta figure out how to clean this up a bit. Anyways, what you actually have to do is start off with the 1 foot. Sorry, 1 foot-pound. I'm just going to use FT-LB for foot-pound because that's the symbol. Equals 12 pounds per square inch times cubic inches. Now, I'm sure some people are confused out there, but it'll make sense in a second. Now, with exponents like this, all you have to do to get rid of the one at the bottom is put the entire thing under multiply it by a larger or equal exponent. So you just get rid of that, and then minus the 2 from the 3, giving us a 1, meaning that's now inches. So that's 12 inch-pounds. Now, okay, so 1 foot-pound equals 12 inch-pounds. And this is the final thing that most people don't think of, but because you actually have to do one last calculation. I know this is something that we all do, but this helps to prevent screw-ups like this. So multiply that by 1 foot per 12 inches. Cross out 12 inches. Cross out 12 inches. All we have is 1 foot-pound. So 1 foot-pound equals 1 foot-pound. Now, if you follow me, you can see why 1 foot-pound does not equal 12 psi. Alright. Now you take this into his actual equation, and you start off, he claims that one side of his equation is 10 pounds of weight pulling down, and it moves 22 inches. So that's 220 inch-pounds, which I'm just going to leave it there for sake of ease. It doesn't really matter, you all know what that is, right? So, now on the other side of the equation, we start off with the 120 psi that he claims, so that's LB over IN squared. Now, we want to get this over to inch-pounds, though, so we can't leave it like that. So how do we do that? It's actually pretty simple. All we have to do is multiply by the area of the cylinder he used. Now, unfortunately, I don't know exactly what that is, so I'm just going to use a rough guesstimate of 2 inches, which looks about right. It might be a little more, might be a little bit less, but really it doesn't matter, seeing how far he's actually off. So, we all know the formula to figure out area. That's just pi r squared, right? So, yeah, pi is 3.14, just for the sake of ease. And 1 squared is always 1, so we get 3.14 square inches. Now we multiply that by the 120 pounds per square inch. Alright, and inches squared cancel out, so it's just 120 times 3.14. I'm going to be lazy and use my calculator at this point. 14 times 120, and that gives us an answer of 376.8 pounds. Now, you're saying to me, wait, we're still not at the foot-pounds that you say, inch-pounds, whatever, that you said we're going to. Well, that's where the last part he said comes in. He says the thing, the cylinder that he had there, piston he had there, moved about 8 inches. So, we multiply 376.8 times 8 inches, and we get 3,014.4 inch-pounds. We can see now that the amount that he's claiming that work it's doing is 220 pounds. The amount of work being done by that system is 3,014.4 pounds. Is there any wonder why this thing works? Because, I mean, it's not 800% over unity. It's not over unity. It's not unity. This is just a standard equation. I mean, he just simply forgot to to include every part of the equation. All right. Good night, all.